And welcome everybody to the Daily Space Weather. I'm your host Dan, aka Smash-O-Mash, coming at you from the Smash News Network, least busted name in news. We're going to be showing you all kinds of features, solar features, practically all of them. It's the weather of Earth and space together. This is the past 24 hours from SDO, featuring 94 plus 171 angstroms. We've got a huge sunspot there, right north of the solar equator there, moving into the western side. We've got some active regions setting in the northwest and the southwest. A series of sunspots rising in the southeast, and a tiny sunspot rising in the northeast. At least one. Anyway, here are some more additional views for you. More additional views. I know, that sounds silly, right? Another 24-hour video from SDO. Here's this new small sunspot that rose. There may be some more umbrae behind it, but when we did show prep, all we saw was one small umbra. Just one small pore up there. There is still a high likelihood of large solar flares from these setting groups. There are actually two groups setting there in the northwest. Those do have they have the possibility of producing a large flare, so we'll be keeping an eye on that. And when I say eye on, pardon the pun. The most interesting place right now as far as new activity would be this group over here. So that looks like a series of sunspots are about to rise there. We already see multiple. And don't worry, we'll show you lots more here in a moment. First, let's take a brief look at what's going on from the HMI instrument there. Looking at the solar photosphere to see the sunspot scenario. So we've got at least two new groups that'll get names today, most likely, maybe three, depending on what's going on up there in the northeast. Here's a colorized magnetogram. These images depict yesterday plus today. And we're going to take a quick look at Earth, but first, take a moment to visit our links. One of the links is our Hemp Lucid link. You can find that right below the video. And today's featured product is the Focus Mushroom Gummies in Grape. Now, I like them. It's not going to make, well, it doesn't make me jittery, so maybe check those out. Shop on the Hemp Lucid shop via our link. You can find it below the video. It's also on our homepage at smashomash.com. Thanks to all of our viewers who've picked up products and increased the likelihood these videos will continue to exist, remain publicly visible, and free for all to view. So maybe check those out. I use them regularly. The Focus Mushroom Gummies in Grape. Tastes great, less filling, and lots more products there available at the Hemp Lucid shop. Money back guarantee, by the way, on the Focus Mushroom Gummies, so you're at little risk there. Feel the difference or your money back. What could you do with 30 days of focus? Today's featured product from the Amazon store is this. It's my pink flamingo Hawaiian shirt. Now, I've been a Hawaiian shirt collector for over 20 years. I've got a decent collection. It's not too bad. Amazon.com/shop/Smashomash. Links below the video to that, as well as on the Smashomash.com homepage as well. Follow us on Instagram for things like diet and lifestyle posts. You'll see some motivation to get on your bike, or perhaps whatever kind of interesting stuff you like to do. Also some related content. Lots of exclusive content over there on Instagram. Today's featured product from the Red Bubble shop is the Do Not Pole Vault the Caldera. Yeah, don't pole vault the caldera. It could be unhealthful. And frankly, we need the views on YouTube. But it's a great time to pick up some products. This is our top seller, by the way. Use the promo code EXTRAVAGANZA for 20% off, but hurry up, because the sale ends soon. So lots of different products available there. The large print featuring both our homepage and the YouTube channel URLs. And of course, the public service message brought to you at massive personal risk and expense by Smash staff and I. If you're going on a volcanic vacation, don't pole vault the caldera. That could have an unfortunate result. We don't want you to become part of the lithosphere. Speaking of not pole vaulting the caldera, check out what's going on at Fuego. Some spectacular imagery there from Fuego. You can see lava raining down from that eruption. It's a lava fountain and a volcanic ash plume. Let's see what else is erupting here around planet Earth. Mount Mayon continues to erupt. It's producing a volcanic ash cloud of unknown size. So again, don't pole vault the caldera. Karengatang, which is, by the way, what is in this image up here. Karengatang, it's an Indonesian volcano. Extruding some new real estate there as block and ash flows travel over the south and southwestern slopes. Popocatépetl exploding in central Mexico. It's a flight level 210, 21,000-foot ash plume. And Fuego, an explosive eruption, persists. Ash plumes extended about 20 kilometers to the west and southwest of the volcano. Ashfall is continually reported in the communities of Panamaque, Morelia, and Santa Sofia. Nevado del Ruiz exploding, flight level 210. Sangay exploding, flight level 200. Sabancaya exploding in Peru, flight level 240. It's a 24,000-foot ash plume. And as far as earthquake activity goes, it has been calm for the past 24 hours. So low levels of seismic activity. Guess how many 5+ magnitude quakes have happened in the past 24 hours? Zero 5 magnitude quakes. The only one that I would note is this one right here. Is that a foreshock there at Guatemala? The possibility of that maybe being a foreshock. That's the only really thing that I've got to note. Although there were some quakes there around Alaska. Make sure you leave us a comment if you did feel an earthquake in the past 24 hours. We're always interested in which one. So drop us a comment for that purpose, or for any purpose, if not just to dope the algorithm. So yeah, 0 quakes of a 5 or larger magnitude for the past 24 hours. A quite seismically calm situation, and it's time to return to space. So here's the past 24 hours in SDO 304 angstroms, ionized helium. Great view of that sunspot there, as well as if you look up in the upper right, you see a massive coronal mass ejection going on. That does not have any earthly directed components. Here we've added 211 angstroms to perhaps provide some additional contrast there. You can see that CME popping off. That was late yesterday Universal Time on June 29th. Also some Hyder flares happening up here. You can see some plasma splashing back down north of this sunspot group as some of those magnetic fields stop suspending some plasma and it splashes back down, succumbing to gravity toward the solar chromosphere. That's the layer in between the photosphere and the corona. Here we've swapped out the 304 angstroms with 171 angstroms. It's another 24-hour SDO video. And let's go through some stats. The 10.7 centimeter radial flux has come up interestingly, perhaps even unexpectedly for some of you. 10.7 centimeter radial flux now at 162 solar flux units. And there is the 1-year graph to put all of that in context. Check it out. The 30-day sunspot average here is now at it just got up to 180. So that is a new high for the 30-day sunspot average. Just achieved, looks like yesterday. Although it has come down since, or 2 days ago, I guess that is. Solon.info is where you can see that data if you like. Space Weather Enthusiast dashboard here. Forecasting a little bit of geomagnetic activity here coming tomorrow because of a coronal mass ejection glancing below, as well as the possibility of a coronal hole interaction. Now let's take a look at NASA's forecast here real quick. So if you look at the integrated space weather analysis page and you click events, you click the Enlil spiral there, and we're going to switch to the inner planets. We're going to use the parameter density. And there is NASA's forecast. So again, going back to the Space Weather Enthusiast dashboard, we are expecting a possible glancing blow impact. I'm not expecting to see it get above a KP6. So it could be a little more intense than forecast here. Keep in mind, when we have co-interactive regions, that does have the tendency to occasionally affect the other phenomenon. So coronal hole high-speed streams tend to affect coronal mass ejections and vice versa when they are expected to arrive at the same time. Next, the past 4 hours of Earth's magnetic moment from space, and it is geomagnetically calm condition. We did see a weak coronal hole high-speed stream arrive, which we'll get to here in a moment. This is depicting Earth's magnetic moment to about 12 Earth diameters for the past 4 hours. You can see most of the pressure there on the magneto-tail side, the non-sun side, and a little bit of an uptick happening there right at the end of the video, just in the past maybe half hour. Here are the past 4 hours of Earth's magnetic moment from the ground. And if you thought Earth's poles are in the process of flipping, then why don't we see any quadrupoles? Why don't we see any octopoles or hexapoles happening? We just don't see them because Earth's poles probably not flipping. Next, the planetary K index, currently at KP 2.33. Again, it is a geomagnetically calm situation. And let's see what that little uptick was caused by looking at the real-time solar wind. So a little uptick happening here. Oh, it looks like a CME impact, actually. Oh, no, it's just an instrument change. See that? This line right down here, we were using the ACE, and now it's using the Discover. So where it switches from green to blue like that, that's switching from the ACE spacecraft to the Discover spacecraft. That's not necessarily indicative of very much. Keep in mind these things are fairly far apart from each other. They're orbiting Lagrangian point 1, about 1 million miles from Earth. Lagrangian points are gravitational equilibrium points where we can put a spacecraft without much use of fuel to maintain its location. So anyway, current conditions are about 11 protons per cubic centimeter for the solar wind density, solar wind speed here, about 500 kilometers per second. Now I would note this weak coronal hole high-speed stream here. It's quite weak, as you've got right in here. So right there is the arrival of a coronal hole high-speed stream. Very weak, as it only went up to about 4 protons per cubic centimeter for the density. Density comes down, speed goes up, and you can see this signal on the bottom. That is the plasma temperature. So it's a weak coronal hole high-speed stream. Again, we're expecting some activity coming mid to late day tomorrow in the form of both more coronal hole high-speed streams and coronal mass ejection impact. So here's the GOES magnetometer, looking a little bit sawtoothed for the past couple of days here. Again, there has been a little bit of activity there, but it's quite minor. And next, looking at the heliospheric current sheet, and this was the news yesterday. So this was the important story that we're very excited about. And check it out. That has snapped back to the north heliographic pole. So you see this green blob here? That's a coronal hole leaving and moving down toward the solar equator and then snapping back again. So this was actually forecast. I said, well, there's a possibility that that could snap back to the pole, and indeed it did. So that is still a feature that we are waiting to see leave the north heliographic pole. And when it does, the stage is set to run straight up to solar maximum. So we may see a major increase here. We're waiting for that green blob to move down to the equator and stay there, as the solar polar field reversal process has to happen. Anyway, it's important to note the magnetic fields of the closest star. And if you look at the green, red, and blue there, those are the coronal magnetic fields. So, the green solar polar field there is the north, the red solar polar field is south, and the blue is the B field, which is the field that goes through the magnet. It's essentially a net of the overlap of those polar fields, and the grayscale portion is the magnetic field of the magnetic fields of the photosphere. So it's important to understand the distinction there. There is a layer in between there called the chromosphere. So the gray shows the photosphere, and the green, blue, and red show the coronal magnetic fields. The solar plasma has its own magnetism, and as you can see there, it is quite separate from the magnetism in the photosphere associated with sunspots and active regions. Next, moving to coronal holes, there is our line of sight coronal hole plot. And we have some south pole oriented coronal holes popping in here, but looks like they're getting canceled back out again. So that's the situation with coronal holes. And let's take a look at those through the SDO. The 211 angstroms wavelength is a good choice. So here's that. So these aren't super well defined. I mean, you can see this one down here is somewhat equatorial, just south of the equator there. Some more rotating in here north of the equator. And these are North Pole oriented coronal holes. Next, we'll move to sunspots. Those are important for solar cycles, right? Well, we agree. However, did you know that I actually think coronal holes are a more important feature to the solar cycles than sunspots are? Yeah, it's true, folks. It is my belief. Anyway, so here is our flare probability monitor and active regions. Again, we're going to have 3 new sunspot groups. So we're going to have one new group likely named over here, one likely over here, and one up there. And let's take a closer look here. There are the past 24 hours from the SDO HMI instrument. So this will be a new sunspot. That'll get a name today. This group down here probably won't get named until tomorrow. This group up here might not get named at all. We'll show you high detailed imagery of that. And speaking of high detailed imagery, there's that gigantic sunspot group. It has been quite stable here over the past 24 hours, the time frame depicted in that imagery. Next, we're going to move to solar energetic particles and, of course, solar flares. Those are important too, right? No spikes in the proton flux here, and no major flaring for the past 24 hours. So just only C-class intensifications besides this M flare that happened yesterday. That was out of that huge sunspot group right in the middle of the northern solar disk. We still do have a high likelihood of large solar flares. That most recent one was a C5.75. And let's take a look at flaring. So there's the past 24 in SDO 94 plus 131 angstroms. I have a new most likely spot for a large flare. It is down here in the southeastern limb. That area right there looks promising to produce some large solar flares. How about some closer looks? We've got those. Don't you worry. All right, so next on the list is what's going on overhead. Now, we like to use a star chart from skyandtelescope.org. Just put in your location if you want to. Make your own star chart. There you go, skyandtelescope.org. That's what's happening over Lehigh Valley. as air quality alerts continue. And we've got Jupiter up there on the ecliptic. Once again, if you are viewing the post-sunset skies, Mars and Venus very close together. They're a great time to view those two planets. Here's your solar system forecast. We're going to show you the 1 week forecast here. We've got a full moon coming up on July 4th. There's where things will be on July 7th. And, let me just note that the planets and the barycenter does not control solar activity. That's not the way it works. That's not the mechanism driving the sun's activity. And I've read up extensively in the scientific literature about it. Jupiter and Saturn are not controlling solar activity. Moving right along to our coronagraphs. Here are yesterday's. And you can see that huge CME coming out of the north-northeast right at the end of the video. It started happening just a couple of hours before midnight there. Here is the aftermath. That's 102 frames from yesterday. We don't see any indication that there are additional CMEs headed Earth's way. There's the aftermath portion. It was a gigantic CME. And it was an interestingly homogeneous core that came out of that one. So here's LASCO C2 and C3. And let's also take a look at stereo A. By the way, that's Mercury in that image. So we show this diagram daily also because that is the locations of stereo A, and those are the locations of stereo A and stereo B, also Solar Orbiter, Bepi-Colombo, Parker Solar Probe. And we just show that because, well, stereo A and B are very close to the Earth right now. And it's not particularly helpful when trying to calculate the trajectory of coronal mass ejections. So I'm going to let this play through, and then I'm going to bring it back to just show a little analysis of that core, that coronal mass ejection that occurred late yesterday. It was on the far side of the sun, and quite unexpected, not associated with any solar flares. So let's pause this. And then we're going to bring up stereo A. So this is an interesting one in that it has a very homogeneous core. And, well, it looks like it's actually got some density behind it. Let's see here. So this is a great example of one that would probably have like 2 strikes if it struck Earth. You can see it has a bubble-like feature to it. It would have a slow onset, and then it would get more and more intense, and then probably rapidly wane. We're going to talk about filaments here next. First, let's show the 24-hour custom videos. Let's do it. There are the past 24 hours, SOHO, LASCO C2 and C3, and the SDO 193 angstroms wavelength. Again, you can see how that CME is it's sort of like a bubble-like feature. It does have a small little dense core feature. And, you know, nothing in the universe is random, folks. The more we seem to learn about things, the less random things seem to be. Here is a slightly closer view there as Mercury slides into the LASCO C2 coronagraph. Here's an even closer view. And let's move to filaments. Yeah, filaments. Filaments are totally sweet. And, oh, before we do that, here's the full disk view in 193 angstroms. So solar flare probability at this point, the most likely place for a large flare, in my opinion, is down here. That's number 1. Number 2 is right here. And there is a fleeting possibility for large flares up here, although this group here is nowhere near setting yet, and it is beta gamma class, so we still do have a high probability of large solar flares. So let's move to filaments next. Here is the Gong 2 data. It's derived from ground-based magnetometers and, of course, I'm sorry, not ground-based magnetometers, ground-based hydrogen alpha telescope at El Teide, Spain. And we do have some large filaments down there in the southeast, the southwest, and the northeast especially. This one up here is called the Getty Lee filament, and it looks like it may make its way all the way to the limb there and become a prominence. That filament is based. See what I did there? By the way, if you want to name filaments after living people, make sure you join us over on Twitter. If you follow us on Twitter, you might actually even see the tweets. But frankly, I doubt it, because censorship has not been fixed. Now, before we show that, let's cut back to filaments, because, well, we want to show the sweet filament wavelengths that we picked up from HelioViewer. There's a 24-hour video. So plenty of filaments there. Likelihood of coronal mass ejections remains at nearly 100%, along with the likelihood of large solar flares. There's that northern area once again. You can see that CME kicking off in the upper left. Here's the equatorial view. It's SDO 193 plus 304 angstroms, and there is the southern hemisphere. And we'll be keeping an eye on that southeastern limb to your lower left. And when I say ion, well, you get the idea. Next, the GOES 18 SUVI. And this is the moment where we go to our bonus feature segment. Some flaring happening from this massive sunspot group as we stream the video. That's the last about 2.5 hours there from the GOES. Bonus features, brace yourself. Here they come. We're going to blast through them. Satellite charging hazards are minor. They are of the surface charging variety, and they are on the East Pacific at the moment, moving toward the Central Pacific Ocean. The GOES electron flux here, toying with warning levels once again. I think a little bit higher than expected here. We are expecting to see this crater by tomorrow. So we're expecting a large dip tomorrow by midday or so. Yeah, there's the GOES electron flux for the past 3 days. There's the 1-year graph of it to put it in context. We're at pretty high levels here now. We are expecting a big dip. So I'm expecting this to be way down here tomorrow. That's the NOAA forecast. I am disagreeing with that. And that is measured at the F layer of the ionosphere. So let's show the F layer of the ionosphere, shall we? There it is. It's located at 300 kilometers of altitude. And that's what's going on at the bridge between Earth and space. And let's see. This is looking less anomalously than it did yesterday. Certainly some low-frequency anomalies showing up there, but nothing too major. So let's show the anomalygram as well. That'll clear things up. We're hoping. There it is. That's the anomaly in megahertz from a 30-day median. Actually, some significant low-frequency anomalies showing up there in the East Pacific. All right. There's the latest image. That's 12 o'clock Universal Time ionogram, and that is quite anomalous at that moment. And there's 12 o'clock anomalygram. quite a bit of puffing up happening there, especially over the central Indian Ocean, the Middle East, Central Atlantic, and Central Africa. We also like to show the total electron content. Feel free to pause the video in this frame if you are unfamiliar with the distances to these things in miles. Here's your total electron content forecast, and we do have some significant electron content anomalies. So yesterday, right around when we released our video actually, some significant anomalies happening there, mainly in the southern hemisphere. As you can see, really high electron contents showing up in the Southern Ocean, around Antarctica and so forth. Those are the most likely places to see GPS errors, and those are some pretty anomalous electron contents. These are more common during CME impacts and during coronal hole high-speed stream impacts. We'll let that play through one more time, and then we'll show the North American total electron content. It's literally a count of the electrons from the inner portion of the outer Van Allen belt, the plasma spheres, the inner Van Allen belt, and the ionosphere. 12,500 miles is the distance. Here's total electron content for the North American area. And let us know in the comments if you think we're going to see a 6+ magnitude quake. The time is running out for that forecast, and we like to admit when we're wrong. That induces learning. Anyway, all right, so let's check out this sunspot up here. Is it a sunspot? I think I see a pore rising there. There may be some more active. Oh, yep, I definitely see one umbra. So that's a possible new named group. And oh, check it out. There's growth has happened since we started the show. So it looks like we're going to have more like 4 new named groups. I suspect these are going to be separate sunspots. So that's 1, 2, 3, 4, possibly as many as 5 new named sunspots by tomorrow. So expect the major uptick in solar activity to continue. And let's move to meteorology. Yeah, meteorology. We like to cover the space weather and Earth weather together. Now, I discovered about 15, 20 years ago that forecasting the weather is way too easy. And so, since I have that skill, I needed to move on to harder things, right? Keep challenging yourself, folks. Evolve or die, right? So, because of that, I started getting into the realm of space weather. Here we're looking at ocean currents. That's what the animation is depicting, ocean currents. And the color gradation is depicting sea surface temperature anomaly. Some quite cold water up here. That is 10 degrees, beyond 10 degrees colder than normal for this time of year. And if you think it's shutting down the North Atlantic Oscillation, well, the answer is no. I see currents that are making it to Ireland and Iceland. So we're just waiting for everybody's prophecies of doom to come true, except they're not coming true, because these are not based in any reality. They're just, I think they're based on an ancient and long debunked paper published in 2015 forecasting a grand solar minimum, which is not a thing that's occurring. And if one does occur, you've got about 20 years to wait for that. You need 2 consecutive week solar cycles in a row, folks, and we ain't got those. So anyway, that's sea surface temperature anomaly and ocean currents. We'll show the whole planet here just briefly to show you the temperatures of the oceans. There's the Atlantic. There's the Arctic. How about the world's largest body of water, the Pacific? And La Nina has ended. There's the Indian Ocean. Pretty normally temperature there. And there is the Southern Ocean. Next, we've got the windy.com satellite. And by the way, folks, take a moment to press like and subscribe if you enjoy the content. Tell your friends and foes about us. Press the share button, as we think we need your help in order to get the video onto screens. So that's we would appreciate it if you pressed like, left a comment, etc. Thanks to everybody who supported the channel over the past, 6 years. Here's the satellite imagery depicting the Atlantic and the Pacific. And it's just getting light over the Midwest. Great visible satellite there from Windy.com's free app, which you can download to your smart device, which is probably about as smart as a, well, smart devices. They're real smart. Pardon my sarcasm. So here's what's going on as far as clouds and fog. And I'm unable to do the most basic functions of my PC today. This is clouds and fog over the Americas. Great equatorial cloud band there. And we've got rapid cloud nucleation happening over eastern Kentucky. That's 3.9 micrometer infrared radiation. And here is your weather.gov map. Yeah, weather.gov. Highly recommend you check it out if your location's lit. Those are air quality alerts, all of that gray stuff. As Canadian smoke continues. Also, excessive heat warnings over large portions of the U.S. If your spot is lit, head to weather.gov and click your location. Here come some forecasts. So there's your smoke forecast. From firesmoke.ca. And it is going to be very smoky along the entire east coast of the U.S. there. At least according to that forecast. And we did put out a short showing the haziness of the Lehigh Valley yesterday. It is indeed a little smoky. I mean, it wasn't as smoky at not even close to as smoky as it was during round one, in that I couldn't smell anything. So my eyes did burn at the end of the ride, though. So I probably accumulated a bunch of smoke on my face and stuff from sweating, and then it ran down into my eyes. Didn't really seem to do any damage, though. Here come some forecasts. And once again, thanks for tuning in to the Smash News Network, least busted name in news. That's your jet stream forecast, and since the jet stream is largely in control of moving major weather systems from west to east, we like to show it. It's going to be incoherent over the U.S., so you're going to have funky weather patterns once again. It's going to cause people to think that chemtrails equals geoengineering and that HARP equals geoengineering and yada, yada, yada. When you have an incoherent jet stream, you'll have weather systems moving in odd directions. And you can expect that in the coming days. That's your 250 millibar wind forecast based on the GFS 72-hour model. Next, your temperature anomaly forecast, and going to have anomalously cool temperatures in the center of the country, and that'll be surrounded by anomalously warm temperatures. So lots of high temperature anomalies, especially here. That is the GFS 72-hour temperature anomaly forecast in degrees Celsius. Last but not least, pressure and precipitation. And we definitely have some strong storms expected, especially in the center of the country, and moving their way east in the next 3 days. 72-hour GFS pressure and precipitation forecast. Here's your lightning mapper. And you can see right there a system making a turn from Kentucky to Tennessee and making a turn to the south. Most weather systems, again, move from west to east. And right there is an example of an incoherent jet stream failing to do so. Next, our lightning mapper from lightningmaps.org. And this is a real-time lightning map. We'll only show this briefly. We do have indeed some lightning here. So there's where the things were when we recorded the video. Keep in mind this video was not streamed. It was actually recorded. And to all you people who like to view the videos on Twitch, sorry about that. We needed to upload the video instead. So anyway, please support the channel. Consider becoming a member of the Smash team if you haven't done so. It's the official subscription services site of the Smash News Network, Least Busted Name and News. We launched the site back in October of 2021 because, well, we needed additional capabilities. So Patreon did not have the capabilities that we needed, so we expanded them to our own subscription services site. Again, smashomash.com/smashteam. You'll get additional content if you're a gold or silver level Smash Team member. All kinds of features available to gold Smash Team members, like your own @smashomash.com email address. If you join at the 1-year annual paid-up subscription, you'll even have access to complimentary merch. Of course, we are streaming on Twitch. This video is not streamed to Twitch. You can find all of our links at smashomash.com. So thanks to everybody who supported the channel throughout the several years we've been doing it. Again, we need your assistance to keep these videos in existence, so please support the channel in whatever way you are able, whether it's via clicks, likes, comments, shares, merch, etc. Lots of capabilities there. We're going to close things out with the U.S. Doppler radar and some satellite imagery. So there you go, those systems north of Kansas City there, they are moving almost due east at the moment. Those systems east of Nashville are making a turn to the south. Here is clouds and fog. Once again, it's 3.9 micrometer infrared radiation, part of the NASA GOES Interactive Weather Satellite Suite, and there is the water vapor map. And you can see that rapid cloud nucleation happening there over East Kentucky. And there's an impulse of dry mass of air there, once again coming from the north, and a blocking feature to its south, which is creating huge pressure gradients. Here's your recap. It's the end of your space and Earth weather together. U.S. Doppler radar. It shows vertical motion in the air column from ground-based systems. Space-based systems are showing 3.9 micrometer infrared radiation. The NASA GOES Interactive Weather Satellite Suite. And there is the water vapor map, which should clarify things when your Doppler is unclear. Anyway, we hope your space weather content is clear. And thanks again for tuning into the Smash News Network, Least Busted Name and News. I've been very frightened by all this stuff, so I'm going to have to shut off that logo and get back to the bunker before my anxiety reaches. Before my blood pressure reaches 220/100, I'm going back to the bunker. Bye! And while I'm gone, may that solar wind be at your back. Whoa!